So in Turkey, it's quite normal to do a 6-day work week. Their standard work day is from 11 a.m. to 11 p.m. In many of these cases, you're just like working in a kebab shop. One thing that really stuck with me is that they do it with a smile on their face. You realize like how hard life can actually be for people. That knowledge has always served me well. Whenever I'm having like my hardest days, I remind myself that it's still incredibly privileged relative to so many of other people that I could very easily have been living with.
Alrighty, hello everyone and welcome to the Deal Maker Show. So today we have a really amazing founder, joining us. I think that we're going to be learning quite a bit from him. Really incredible story that he's going to be sharing. The building, the scaling, the financing, you name it. We're going to be talking about, his vision, what he's thinking for the next 5 to 10 years, how he went, on pivoting on the business from, let's say, growing meat to under light, to also growing drugs now with light. But again, quite the journey. He's also raised 90 million from some of the top investors. We've actually had a bunch of them on the show, but we're going to be learning, that capital raising journey too. So without further ado, let's welcome our guest today, Deniz Kent. Welcome to the show.
Thanks for having me.
So, child of Turkish immigrants, and you found yourself growing up in London. So, give us a walk through memory lane. How was life growing up for you, Deniz?
I kind of grew up between Turkey and the UK. I think my dad was in Turkey, my mom was in the UK, and I kind of created this strange worldview where I didn't really belong anywhere. And the idea of nationality and nationalism and patriotism always seemed very strange to me. I think partially because I had this strange nomadic childhood where I was constantly going back and forth. I think that I feel culturally more Turkish than British, even though I spent more time in the UK. Especially this like Turkish immigrant mindset, which was very much embedded in me as a child from my parents of like, you need to work hard. It's like earn your keep. I think that has had impacts on my life that have been significant. I think children of immigrants and immigrants generally end up having to work quite hard to find their place.
No kidding. I guess. How do you think your worldview and your perspective, grew and perhaps it shifted or was different from maybe other kids, from having that exposure to two different countries so early? I mean, there's so many people that don't even get on a plane, until they're like in their 40s, 50s, or maybe never. So I think that maybe opened up, a different lens for you.
Definitely. I think it made me more grateful. I remember vividly like that. So in Turkey, it's quite normal to do a 6-day work week. It's not an unusual thing to do. And there are many people that I interacted with a lot who just worked in a restaurant or a cafe in Turkey. And their standard work day is from 11 a.m. to 11 p.m. That's like the length of time that the establishment would be open. But the people who work there have to come, 30 minutes before to set up, and they have to stay 30 minutes later. So they do this 6 days a week. So they're doing just crazy amounts of work. And in many of these cases, you're just like working in a kebab shop, you're like serving people. And one thing that really stuck with me is that they do it with a smile on their face and are generally quite happy to be there and to be serving you and to be helping you. And at the same time, you see a lot of people in America and Europe who are doing, maybe an 8-hour job that is actually much more comfortable than what a lot of these people have to do in Turkey, and are really complaining. It's just a very different perspective when you grow up somewhere that is where there's less opportunity and more competition, and you realize like how hard life can actually be for people. So I think that knowledge has always served me well whenever I'm having like
whenever I'm having even my hardest days, I remind myself that it's still incredibly privileged relative to so many of other people that I could very easily have been living with, had it not been for a lottery of birth on my part.
Obviously, like for you, like you got into this whole world, of science, right? And obviously it has taken different shapes, different turns, like what you've done. But in the end, I mean, you ended up studying at King's College, and you did there all types of stuff, leading all the way up to a PhD. So how do you get into this whole cellular and molecular medicine, biomedical and translational science? I mean, how do you get into all of this, science world?
I was always good at science as a kid, but I was never really that interested in it until I got into the lab and started doing actual lab work. I really dislike the idea that, you just have to go onto a textbook and read something that someone has written and take it as fact. Like, that was something that never felt very appealing to me. But I vividly remember this moment. It was my first job in the lab. I realized that science isn't something that you read in textbooks. Science is something that we co-create. And that was very exciting for me. And that was sort of the start. That was well before my PhD, but that was the start of my excitement around science.
Now, in your case, you started also, really in an immunology lab. So how does that transition all the way, to then, the pharma sector, or even, doing your PhD? I mean, walk us through those sequence of events that needed to happen.
Yeah. So my first gig was engineering T cells, which are a type of immune cell to infiltrate into tumors and destroy them. It turns out that tumors are very good at suppressing the T cell response. So I was trying to figure out what is the mechanism there, and then is there any druggable targets there? That led me to working in the pharmaceutical industry, because I was basically studying how to program the immune system or reprogram the immune system. And the pharmaceutical industry was very interested in that, especially GSK, which is the company that I started working for. They were very interested in asthma. They had invented salbutamol, which is like the inhaler, the blockbuster drug. And they were interested in curing asthma. So I then started a project with them working on a single dose cure for asthma, which was a bispecific antibody based. And that got me really excited about doing science. That was like my first real independent research project. And off the back of that, I thought that I wanted to run my own academic lab and go all in on the science path. And that's what led me to do a master's and then a PhD. But then during my PhD, I realized that there was this big problem around tools to control biology, and those tools not being very good. Initially just a problem for my own research, which is that I wanted better tools, but then realizing that if I could solve this problem for myself, then I could probably solve it for other people too. So then that led to a sequence of events that led to me having the realization that light was the best way to control biology, and eventually all biomanufacturing would become optogenetic. And that has led to the last 6 years of building and scaling Prolific Machines, which is the world's first optogenetic biomanufacturing company.
Now, it's kind of a sequence of events there, because, I mean, being, more like in the academia, doing your PhD, to becoming an entrepreneur, that's quite a long stretch. So how do you go from, like you were saying, I mean, you saw a need, you saw a problem, you saw a frustration that you had there, from doing like a paper or a study to like building a business. I mean, that's pretty significant. How do you get that push to be like, I'm going to build a business around this? I mean, it's just like so outside of what you would typically see on anyone doing a PhD or anyone more like in the science, path.
Yeah, it was definitely not my first thought. My first thought was I could just work at a company and get the company to develop this. And I actually remember speaking to one of my friends who was an entrepreneur. And I was telling him about this, and he was like, yeah, don't do that, because the companies just have too much inertia. If you like take this idea within an established company,
they're just not going to do anything with it because they already have their own agenda set and et cetera, et cetera. That ended up being really sound advice. He was like, if you want to make this happen in the world, you kind of have to do it yourself. So I'd be very grateful for that friend.
What ended up being the business model of Prolific Machines?
It's evolved a lot. And in its current state, it's providing pharmaceutical manufacturing services to asset owners who want to make their therapeutic proteins cheaper, faster, more reliably. And in some cases, it's for therapeutic asset owners who have already tried to make their therapeutic proteins with other vendors and have found that those vendors either haven't been able to make it at all or haven't been able to make it at the concentrations that are required for profitability. And in those cases, we can help those people because it's the problem stems from a lack of control in the manufacturing process, which leads to many of these drugs not being able to get made. So if you have the cells under the control of light, then it's the highest degree of control that you can have over the cells, over both the time axis and the space axis at the lowest possible cost. So this unlocks a number of pharmaceutical products that otherwise wouldn't be able to get made, and unlocks a number of products across a bunch of different categories as well.
I mean, obviously, you guys too have adjusted yourselves to the market, really nicely. I mean, you went from growing meat with light to growing drugs with light. I mean, that's quite the shift too, no? I mean, it's completely opposite things.
In terms of products, they're very different, but in terms of technology, they're very similar. So the three parts of what we do are genetic tools where we can toggle on and off any protein inside of any cell. So this is basically using light-sensitive proteins that we tether to various different targets, and then we can switch anything on and off, any function, any protein. That part is identical between cultured meat and making drugs. The second part of what we do is hardware, so we actually build illuminators that are plug and play with existing bioreactor infrastructure, laser-based patterning devices, all sorts of things. That's also the same for drugs and meat or any biological process. And then the third part of what we do is software. So we have basically these algorithms that learn how to speak biology by experimenting with different light patterns and getting better and better at controlling cells with light over time. That is also conserved between pharma and meat. The things that are different is the sales cycles, the customers, all of the business side of things is quite different. But the science side of things is very similar, irrespective of what you want to make with cells.
And what caused that pivot? How do you guys, decide to do a 180 there?
So there was a multitude of factors. I should start by saying that even though we aren't actively working on cultured meat right now, I still believe that cultured meat is an inevitability when I look at the world's population and the amount of resources that we have and the growing demand for more and more meat. I think cultured meat is going to plug the gap that I see, and I think growing meat with light is going to be the best way to do it. That being said, meat is not very expensive relative to some of the other things that you can make with biology. So it makes sense to start with the most expensive thing that you can make with biology, which is therapeutic proteins, which can sell for thousands of dollars per milligram, relative to meat, which even when we were making really expensive meat, like we were making Wagyu, which you can sell for $1 a gram. And at scale, we believed that we could make it at roughly $4.7 per kilogram COGS. But even then, the amount of money that you can make per gram of thing that you've made is vastly different if it's meat or a therapeutic protein. So basically, the plan is to start with the most expensive biological product and work your way down the cost curve rather than the other way around. Another factor was that there was basically the alt protein winter was kicking in from an investment landscape perspective, at least in the Western world.
Not so for China, interestingly, where cultured meat remained extremely hot because Xi Jinping, and still remains extremely hot because Xi Jinping put it on his list of strategic priorities. So, which I think is very wise by the Chinese.
What was the capital raising process too? I mean, you guys have raised quite a bit. How much have you guys raised to date, and then what has been the journey of getting that money in?
Yeah, roughly 90 million. First check was by the world's leading biotech accelerator, IndieBio. We ended up breaking the IndieBio record for the fastest any company had raised a seed round 8 days into the batch, which was led by Mayfield. And then we broke the IndieBio record again for the fastest any company had raised a Series A, which was roughly 6 months after our seed round, led by Bill Gates' climate change fund, Breakthrough Energy Ventures. And then last year we closed our Series B, which was led by one of the biggest dairy conglomerates in the world, Fonterra Group, out of New Zealand.
And how do you go, from raising a seed to then all of a sudden you raise, within 6 months? I mean, that's unbelievable. What would you say has been your biggest lessons when it comes to raising money?
Fundraise when you don't need to fundraise.
How so?
If you don't need to fundraise and you're fundraising, then you have a lot of leverage. And if you have a lot of leverage, then you can get deals done. But if you're fundraising from a position of weakness, then you may not get the deal done at all. And even if you do get the deal done, you may not get the deal that you want to get.
No kidding. Now, when it comes to vision, because I mean, obviously, all of these investors, also your employees, ultimately they're betting on a vision, no, on what the future, holds. And if you were to go to sleep tonight, Deniz, and you wake up in a world where the future of Prolific is fully realized, what does that world look like?
I fundamentally believe that all biomanufacturing will eventually become optogenetic. And that was an extremely contrarian position to take 6 years ago. It's actually becoming less and less contrarian as we're generating the data to show that that is true. But still, the vast majority of people would disagree. The reason why I believe that is because of the fundamental properties of light. So light is the cheapest possible input into cells because LEDs have been commoditized by consumer electronics and electricity has been commoditized by civilization. So relative to all of the other inputs that we have, light is by far the cheapest and will always be the cheapest. So we're the floor for how cheap biomanufacturing can ever be. But that is not in and of itself why I have such conviction. It's because that is coupled with the highest control that biomanufacturing can have, because nothing can beat light in terms of spatial or temporal control, meaning that you can very precisely control where you shine it and when you shine it. And you can do that instantaneously and tune it to any desired level. We can't do that with traditional inputs into biology. So traditionally, we'll use molecules. When you add in the molecule, this is my tea here, it's my scaled down bioreactor. If I imagine I add the milk to my tea and you watch the milk dissolve, you can't control where the milk goes. And you also can't control when it goes, where it goes. It's just gonna do what it does, and it'll move stochastically. That's a problem in a bioreactor if you want to, for example, have something switch on and then something switch off, and then a different thing switch on and then switch off, which you frequently want to do. You want to be able to toggle multiple things in order to make stuff. That's really hard to do with things that move around randomly. And if you want to create patterns, it's also very hard to do that with molecules that move around randomly because your patterns are going to be random. But frequently, we don't want random patterns. We want patterns that have a lot of specificity that are associated with, a certain type of tissue or organ. So basically, I believe that there's a multi-trillion-dollar biomanufacturing opportunity, and I believe that whoever will win that will have the lowest possible cost and the highest possible control. And I think Prolific is that.
So we're talking here about what you want, but I want to talk about what you don't want. And in that case, what are you afraid of, Deniz? I'm really curious to hear your response on this one.
I think there's a couple of things I'm afraid of. One is that with any new technology that is powerful like this,
it can be used for good and it can be used for ill. Making sure that it doesn't get into the wrong hands and used for things that are not good. I think that's one of them. The other is that for some of the applications that we're pursuing in the long term, not with drugs, but with many of the climate applications of this technology, I do worry and fear that they will eventually get the attention that they deserve, but they'll get the attention once things get so bad that, like for example, with cultured meat. Like when do I think cultured meat will actually get scaled? It's probably when the environment gets so bad that crops start to fail in the fields and it starts becoming really, really hard to grow animals outside. And so the price of meat starts to skyrocket, maybe combined with some famines. And that leads to, and maybe some zoonotic disease outbreaks. That creates basically a perfect storm where meat goes from something that, everybody can afford to something that very few people can afford. And then that makes everybody realize that we actually should have been investing in scaling cultured meat faster and sooner. But then it will likely be too late, not for humanity, like humanity will survive, but too late to have avoided a lot of suffering, both human suffering and animal suffering. So I guess I fear that humans will be very reactive and not proactive. And I think being proactive would be good.
So talking about being proactive, but being proactive about getting into a time machine, right? And going back in time, Deniz. And I'm bringing you back to that moment where you started to experience that frustration, right? When you were doing your PhD. And let's say I give you the opportunity of having a sit down with that younger Deniz, maybe like seven years and a half ago or so. And you're able to give that younger self, that younger Deniz, one piece of advice before launching a business. What would that be and why? Give me what you know now.
Spend less time worrying about what other people think and just do what you feel like is the right thing to do and focus on that and ignore the vast majority of people.
How do you think for you, being worried about what other people think, how do you think that has gotten in front or in between you and being effective?
I am someone who likes being liked, and I am a people pleaser. And so I have really spent a lot of time trying to work through that with executive coaching and coming to terms with the fact that, the best CEOs aren't always the most liked. And sometimes you have to do stuff that people don't like. And that could be like investors don't like, or that could be your employees don't like, or partners don't like. And that doesn't mean that they're not the right thing to do. And so I've been really coming to terms with that more. And that's part of why it's a shitty job, is because you frequently have to do stuff that people don't like that makes you not liked, but it's still the right thing to do from a fiduciary perspective. Suppressing people pleaser tendencies.
That's powerful stuff, Deniz. I really appreciate you for sharing that. So for the people that are listening that would love to reach out and say hi, what is the best way for them to do so?
Follow me on LinkedIn, Deniz Kent. I have a Substack where I'm going to start writing essays. I have one on Prolific. I'll be writing more. I've just finished a novel that'll be coming out in the next 12 months or so, or 18 months. So follow me on LinkedIn and you can read about it. And also look at our website, www.prolific-machines.com. And if you are a therapeutic asset owner and you want to get to higher titers or lower costs, you should reach out at partners@prolific-machines.com. Or if you want to reach out personally, that also works, Dennis@prolific-machines.com.
Amazing. Well, easy enough. Well, Deniz, thank you so much for being on the Dealmaker Show today with us. It has been an absolute honor to have you.
Thanks for having me.